Hi guys, let us discuss this question which was present in NEET 2023. The question is, the reaction that does not take place in a blast furnace between 900 Kelvin to 1500 Kelvin temperature range during extraction of iron is option 1 Fe2O3 plus CO, which produces 2 FeO plus CO2, option 2 FeO plus CO, which produces Fe plus CO2, option 3 C plus CO2, which produces 2CO carbon monoxide, and option 4 CaO plus SiO2 produces CaSiO3. So this is the question from the basic concept of chemistry chapter mentioned in the NEET syllabus. Now let's discuss this. If we really know the structure of the blast furnace and their the temperature where the reactions happen is different chambers, then we will understand that this is the simple version of this. Let's assume blast furnace where at the top the general temperatures are nearly the 400 Kelvin, and at the down there is a 1800 Kelvin. These are all iron ores. Now in the lower temperature, mineral of iron oxide reduces to mineral of iron 3 oxide, which reduced to the iron 2 oxides at low temperature. That means this is happen in nearly 500 Kelvin to 800 Kelvin. So at nearly the top temperature here, the iron 3 oxide Fe2O3 plus CO, which gives the FeO iron 2 oxides. And at the high temperature, FeO reduction to iron and slag formation happen. So this is the reduction FeO plus CO, which gives the Fe plus CO2, and also the carbon plus CO2 gives the 2CO. This reduction at higher temperature happen, and this is called the slag formation, where CaO plus SiO2 produces calcium CaSiO3, calcium silicate. This is the slag formation. So reduction and slag formation here, this slag form here, and this can eliminate from this here, center, and the iron, which is from iron 2 oxide to reduced to iron, that is the molten iron, are collected here. So all this happen in the higher temperature. So that means only this iron 3 to iron 2, which is not happen in the higher temperature. So here the correct option is the option 1. This reaction does not take place this high temperature. So thank you guys.